Good morning, GMGM. Thank you, everybody here, for choosing to spend your time at our third inaugural NoirCon.
Everybody, thanks Tomer and thanks Carson for the introduction. The goal of this presentation is to show you in under 1 hour what we can do on Stellar, and hopefully at the end of this workshop, you will be able to yourself do your smart contract on Stellar and be able to prove something directly on the network. So a bit of who I am. I'm Pamphile. I'm French, but living now in Austria, working for the AHA company as a principal engineer. And I dropped some links below. Feel free to connect, to reach out if you need any help building on Stellar. The important one maybe is if you connect to Discord, you can find me under Tupui. That's my handle. And also on GitHub, I'm under Tupui. Tupui is my second name. Just a quick note. All right, so what are we going to do? So first, I'm going to present you what Stellar has to offer in terms of ZK right now. And this year has been put forward by the Stellar Development Foundation as the year of ZK and of privacy. And so we want to show you what comes into the next protocol updates. So protocol 25, we call it. And after that, a bit of developer experience tooling, going to show you how to do something on Stellar quickly. And finally, the moment we're here for, how to do ZK on Stellar. All right, so welcome to ZK. So thanks to protocol 22, which was aired something like a year ago, we get direct support on the chain to the BLS curve, so BLS 12.381. And in just these 3 lines of code, so, well, mostly just 2, you're able to actually have the BLS curve, and you're able to do some operations such as addition, multiplication, subtraction, and all of that. What that opens is a lot of possibilities. So first application that we've seen in the ecosystem is something that I've actually done some anonymous voting platform, leveraging some classical Pedersen commitment. And here I just wanted to show you how easy it is to do something. So on the left side, you create your votes. So you have some integers, some randomization factor. So things that I'm pretty sure this room are acquainted to. You define your generators in a few lines of code with your DST. And afterwards, you have the commitment themselves, which are just a few lines of code. So multiplication, addition, all the things you already know. And all of that directly can happen in your smart contract, in your Stellar smart contract. And so you're able to build privacy-oriented application thanks to that feature. Now, this year, Stellar has made some announcements towards privacy at Meridian, the conference, which was just a month ago in Rio. And there's protocol 25 coming in. And we're going to get at least these 2 new additions. So maybe there are some other things cooking, who knows? But there's this BN254 curve, which is widely used in the community, in the ZK community. And there is Poseidon 2 hashes functions. There's already a preview which is available, so you can follow on that link. So Jazz22, is somebody from the foundation, so he's a core engineer at the foundation, and he's actively working the protocol on these features. And he's put up a nice quick start guide on how to get started from scratch with that, if you really want to get your hands into it and experiment with the latest changes. So we have curves, but ZK, you need verifiers. And so there is 2 big names now in the space, so RISC-0 and, of course, Noir. And depending on the system you use, you know that we need different primitives. And thanks to the addition of this BN curve, we can do now ultra-honk. And so there's been a Noir grant, which has funded some work to develop this ultra-honk. And so we have here Hugo, who was part of the team developing that proofer. And so now on-chain, we can actually verify proof on Stellar smart contract. These are links if you want to have a look at. I'm sure we'll find a way to share the PDFs and all of that. So moving on to the developer experience. When you start to do something on Stellar, these are the 3 resources that I often give people. There is a great CLI on Stellar, which is, we're very known for developer experience, thanks to partially to that CLI, because it's just a Stellar, and then you have a breadth of commands to help you do something, from funding an account to starting a local node. So you can just start a local node thanks to that command. You can invoke smart contract functions, even do transaction with it. So it's very a handy tool. And not just for development, there are also people using it just to do normal transactions now, because it offers that capabilities. And second, there is a long-term partnership in place now with the Open Zeppelin. Here there's a lot of smart contracts you can start with. So if you know Open Zeppelin, they are famous for their wizard. And you can go on the wizard page, and now there's a Stellar section to actually start to play with Stellar smart contract. And last but not least, and I will, in the follow-up, continue on that, there is a tool that we are actually developing for the foundation at AHA Company, which is called Scaffold Stellar. And it's allowing you to start very quickly to have, if you want to build a dApp linked to a smart contract, it's giving you that a sort of template, which is rebuilding on the fly when you make change your contract and your UI, and deploying as well all the contract and everything onto your local machine. And you can also set it up to talk to testnet and mainnet. So it's a very powerful developer tool, which can get you started in like 5 minutes. Okay. Now it's the part where I'm showing you how to do things. All right. So let's quit that. Yep. So I want to start with a small motivation example, which was made by Tyler, which is one of the developer advocates, also the foundation. So you can, on his GitHub, he's putting a lot of resources and a lot of examples. He's recently made a lot of things around passkeys, because there was also a new addition with the last protocol updates. And he's put up some nice demo with some ZK maze, for instance. And so he built an application like that to do so you have a maze, you solve it, and then in the browser, it's creating a proof, and then it's validating the proof with Noir and BB. And so it's a pretty nice demo to play with. It's deployed there, you can have a look, and the code source is here. And that thing was at first only running on the browser, and the proof was also just validated on the browser. So, and because we're in the process of building all the tools and using all these new additions to the protocol, and recently we're a few weeks ago able to move that small demo to, well, here there's less visual aspect to the demo itself, but it's the same maze itself. And here we actually, this application is talking to a real RPC, which is talking to a node, so a personal node from Tyler, to be able to run that demo. And so this is running on a Stellar node, a local node. So it was one of the first proofs that was able to be validated on Stellar, if you want to say. The code itself, again, is also on the repository of Tyler. And now I'm going to move to the demo I wanted to show you, this full-fledged example, available as well open source on my repository. So again, Tupui on GitHub, very easy to remember. And then that's what I'm going to show. So I'm going to switch to an editor and to show you the live demo. All right. So yeah, I think it's big enough. Yeah. So the application itself is very simple. The first time a friend explained to me how circuits are working, I understood it in the way that, okay, you have a big matrix and you have columns, and when you're trying to fill that columns, you have to respect some constraint. And so I thought to myself, it's a Sudoku. And so the first application I wanted to try to code on Noir was a Sudoku. So here I made a Sudoku example, and I'm using the Sudoku as a way to show you how it works. And there is a bit of game in the sense that if you solve the Sudoku, you get a prize pot, and if you don't solve the Sudoku, it's going to take some fees to play that game. So it's a small example which I think is demonstrating the power of everything. So this example is using the ultra-honk verifier approver that Hugo made. And so you have the prover itself in the contracts. So you have the contract of the game itself, and you have the contract of the prover itself. A quick note here on the state of that prover. It's changing every day because the team is still actively developing it. And so it's great to see, and now they are really working hard on making this available on FutureNet, because we have FutureNet, testnet, and mainnet. And FutureNet is where all the current developments happening, all the protocol 25 new things are available now already on FutureNet. So the BN curve and everything, but the prover itself is still a smart contract and still need to be deployed by yourself. And they are working on reducing the cost of that smart contract to make it efficient to run. So this repository, to make that example, we are using Scaffold Stellar. The only different thing with a normal deployment of Scaffold Stellar is that you need to start a local node on your machine which has no constraints, so it's unlimited. So this is what I'm doing here with this line. And this line, of course, is actually just starting a local node on your machine. So I just ran it previously before starting this presentation. And here you can see locally on Docker, I have a node running, finality of 2 seconds locally instead of the classical 5 that you have on mainnet. So it's very handy and convenient to actually be able to have your node like that to play locally, to see events and all of that. Put this away. All right, and what I was telling you about the scaffold is that behind the scene, every time you change something, it's redeploying your contract and running all of that. And so here we have everything running here, and the application, the RPC is available. If I would change anything, so just making a change to show you that something's happening. So I'm changing this, and you see behind the scenes recompiling the contract and redeploying the contract on your local node. So it's a very handy tool to do that. Before going into the code and all of that, I'm going to show you how it looks like, what it does actually. And that's going to be a bit more interesting maybe for you. Give me 1 second. Trying to move the window. Where am I? Okay. Oh, cannot move the window. No. I'm trying to exit the. Hey. I'm in full screen mode, but I cannot exit. Okay, let me quit that and restart. Okay. So. Okay, let me restart the demo and everything. Why it's going there? Okay. All right, so it's a real demo, you see. All right, so we're here. Why? There's an error with the mirroring, sorry. Here we go, sorry. All right. So that's the application itself. The application itself, so on Stellar you have many wallet providers. and the wallet which is developed by the foundation itself is called Frighter. And you can set it up so that it connects to a local node. And here we're just going to, where was it? Here we're just going to connect to a random wallet. And that wallet, so with Freighter directly, you can fund the wallet with test tokens. So I'm just going to connect. It's not showing the logo because it's calling outside, and I don't have internet now. So it's really showing you that it's running locally then. And here's the example. So here I have a price pool. I can add some token in it. So let's add 10 XLM. Here I'm confirming. Of course, once again. Right. So here I'm signing this. Okay, so it's executing the transaction, and now it already added that. All right, and now we can actually play the game. And so the game, as I said, is to solve the Sudoku, and if you manage to solve the Sudoku, you will get the prize pot. So the grid, so here you can generate a random grid, or you can load an example. So here I'm loading an example, so that you don't see me doing that live. And now I can actually generate in the client the proof itself, and then that proof is going to be sent to my local network. And so this is what I'm doing now. I can confirm. And at the bottom, it's going to show you, exactly, it's showing you that we just verified something on Stellar. We just verified the proof, the Noir proof, on Stellar. Just what happened. Thank you. And so you can see that the price pot was taken, and we could do another example where we fake it. So we do, as you can see, you have 2 free here, and if I validate the grid, it's telling me that. I can try to regenerate the proof. You see it's going faster because it's doing a simulation, and the fees as well, they are lower because it's already know in the backend that it's not going to actually, it's going to fail earlier. And so that went to the smart contract itself, and the smart contract here failed. So just showing that we validated a proof, and we also validated that we sent a wrong proof, and it was not validated. So that's the example. Now, going to the code itself to show you how hard or easy it is to do that. Okay. Yeah, that's what I'm, all right. Is it okay like that, or you want more? I can do this. It's good? Okay. All right. So the repository itself, so you have the contract, the smart contract themselves, they are under the contracts. The Noir circuit, they're here. So maybe we can start with the Noir circuit quickly. Let me zoom in. So it's a fairly short circuit, so 35 lines. And here I'm just checking like a standard Sudoku, so a 9x9 grid, and checking that you have on every row and every column like all the numbers, and that in every sub-quadrant you have also 1 to 9. And so nothing very complicated. So to check that, I'm just doing some sum to 49, because the sum of 1 to 9 is 49, and then also squaring to ensure that you actually don't have duplicate numbers. So just a bit of math. It was not audited. I'm not a security expert either, so there might be some issue with my solution, but it seems to be working. Here you have a bit of examples. So this should look familiar to you, I suppose. And for me, it was actually my first Noir program ever, circuit. And so I'm quite happy with the result, and it was quite easy actually to do that. So, all right, so you have the circuit here, and then moving on to the smart contract itself. As I said, the verifier itself is on this folder, but it's mostly, I did not touch it. It's really the verifier that Hugo provided, the prover. And then the smart contract itself. So let's have a look. Who here has ever done some Stellar smart contract? 1, 2, 3, 4. Okay, so still many newcomers. So welcome. All right. So Stellar smart contract, they are written in Rust. and in Rust, no STD. So that's the main thing you need to know. And then there is the SDK, and the SDK provides everything, basically. It provides everything, including the ability to do smart cross-contract calls. And so to do some smart cross-contract calls, you don't need to do what I'm doing here necessarily, but here I'm just loading the WASM of the other smart contracts to have some bindings so that it's easier for the ID to play with the contract. So what do we do? In a Stellar smart contract, we have this concept of constructor. So it's a function which is executed as soon as you deploy your contract. So here I'm defining an admin. I'm saying that I want to play with the XLM token. I'm already putting 10 XLM on the contract instance, and that's it. I left some functions for people if they wanted to improve the examples. And this is the main function that we're interested in. So if you're new to a Stellar smart contract, this require auth is one of the super powerful features that we have. This is handling the authentication and ensuring that when you're calling that smart contract function, it's being properly authenticated and signed by that address. You don't have anything to do besides doing that. So it's a very powerful mechanism. So here I'm checking that the person who's playing actually is the person who has the right on that account, basically. And here I'm just taking one XLM when I do that. I left a bit of comments to explain what's happening. And the proof itself, the verification of the proof is happening here. And so here I'm just making this one smart contract call, cross-contract call. I use this try construct because in order to be able to catch panics and then to do some error handling. Because in that case, I wanted to have this game where if you panic in a Stellar smart contract, it's going to just not do the transaction, it's going to error out and nothing's going to persist on the blockchain. And so the way to actually have something failing and still having a logic continue and the contract not erroring out is to do these try methods and to actually catch all these errors. So that's what I'm doing here. I'm catching the error and then I can have this logic of I'm giving a payout or I'm taking some fees. So some very standard Rust. If you have questions, by the way, feel free to interrupt me if you want me to go deeper into something. So that's how it works. And then the price spot itself, you have some function to see the balance. Here I have the function to add the funds. But yeah, as you can see, it's very contained. The example is very readable, I think. It's some classical Rust. And yeah, basically that's it. With this, we're able to verify a proof, any type of proof on Stellar smart contract. And the rest of the repository is just the front end basically, and the handling of the wallet, and all of that is provided by Scaffold Stellar. So you could fork this repository and right now change the circuit, put your own circuit, and start doing something on the Stellar smart contract platform. Yes.
Question: what interface does the ultra-hung contract expose? Do you use your verified proof? Is there anything else?
Yes. So actually, let me. Oh, yeah. So one good thing about this scaffold is that you have this debugger thing, which is automatically parsing all the contract that you have in your repository. And in that case, we have the verifier contract. And so here are all the methods that we have available. So this verify proof, you can set the verifier key directly, because in the example that I was, well, in my application, I was always passing a VK as a JSON. But you could set that, and there is a verify proof with stored VK as well. So you can do that. So in my case, for instance, you could say that so my game has a variable puzzles or type of Sudoku grids. So because there is the classical Sudoku, the 9x9, and there are other rules of Sudoku, and so I might be interested in changing the circuit, the underlying circuit, and so changing the VK. And so here I could use that to set a different VK. But if you had a more like a stable circuit, you could just use this, for instance. Set the VK and then just use the this method, which will cost less because you will have to send less data to the network. Yes? Yeah, so for this specific example is 0.87 because when we started to develop that, that's what we settled on. So yeah. Yeah. Yes. Yeah. So this application, so everything running on the browser, it's making the proof on the browser, and then it's just sending the proof on the network itself. Okay. Yeah. Yeah. Yeah, I mean, it's with all this system, it's like when we make a protocol update, you get a new set of features, and you need to have a certain reasonable version match. And it's the same here with Noir. You need to have a certain version match between the JavaScript SDKs and BB and all of that. So yeah, the whole tooling, you need to be careful about all the versions. But it's getting better. So this contract itself is just deployed on my local node. And if you wanted to play with this example, today you need to do that as well to run on your local node. But Hugo is working on be able to deploy that to FutureNet because we're just adjusting and making sure that it does not cost too much for the network to be running there as a smart contract with all these features. Because right now we need to be an unrestricted node with unrestricted limitation on the smart contract itself. But right now the footprint is a bit too much as we want it to be. And so we're trying to work on reducing that footprint. Sure. So you have all these functions, and the last one is verified. So here it provides just a way to check that the proof was already verified or not. And so you could use that in my game. I could use that, for instance, as a way to verify that I'm the first one to actually propose the solution, and that nobody played with that solution before. Yeah.
From a deployment strategy perspective, is the idea that there's going to be one singleton of like the ultra-long verifier on the network and then everyone interacts with it?
Yeah.
Or that every app deploys like their own instance? And I'm asking because there's like a set VK function here, which implies that this might be like a stateful contract.
Yeah, so I would imagine that we would be able to have just a contract which is bare in the sense that it just have the verifications part, and that you would have other people building on top of that and adding this set VK and verify. But yeah, and I mean I don't know if that would make sense to even put that directly as a host function on the VM. That's also a possibility. I think everybody's open to discussion at the moment. Mm-hmm.
What's the limits of cycle time? Like I see that in another part of the solution.
Yeah.
Was the first 3 excellent for verifiable proof.
Yes.
Yeah. I think about I have one big proof. Yeah. What's the limits for because the block has a size, yeah, for big yes.
Yeah. Hugo, did you play with that, or like with the size of the proof itself and the limitations there, or not much yet? Yeah, so I mean, so this right now it costs 3XLM because the function in like that version of the verifier was not yet using the new host function, and so they had to implement themselves BN 254 in the smart contract and to call external functions and all of that. So it's way bigger and it has to load a lot of things to do a lot of operation, which are not going to be necessary when it's like fully deployed. So by the time it hits testnet, the situation won't be like that. It won't cost 3XLM to make a proof. No, not at all. Sure. Do you have more questions? No? Yeah, I mean, otherwise, that's about what I wanted to show everybody. I'm going to stay around if anybody wants to play with Stellar Smart Contract and to kickstart maybe something. And I'm happy to take any questions. And yeah, we're really looking forward to see what you can build and what you can do on Stellar. What, sorry? The one hello world, I mean the one hello, whoa. Yeah. Wait, have it here. The one hello world is just calling this this function basically. It could be this verify puzzle, and you remove all of that, and you just have these two lines. I mean, even that line, well, yes. Let's say it's these two lines plus this verify. So that would be the hello world. Here, I just wanted to show you a more like how it could look like in a real app with a business logic. Sure.
What's the name of the version?
What's right? The I mean, if you go to Tupui, look at some of the latest commits that I've done. But it's Ultra Hong's Soroban contract. Yeah. Sure.